What?
Plugs, soldering things.
Solder, yeah, we are, but we're gonna get yours first, and then we're gonna.
All right, well, Mark is gonna talk about putting ends on cables.
No, what we've got is a build project, you're needing some time, is what I hear.
Okay, well, since Gary took a long time with his email announcement, I'll make this quick. I don't need that. I don't need that.
No, the
Pretty
deaf
soon you-
people can't hear you.
You don't, they do.
Pretty soon you're going to have all kinds of wire around. If you're new to the radio, you might have one or two, but pretty soon you're gonna have a lot of wire lying around. And if you coil it up, like I did forever, you have to find a place to put it. It'll get in knots and it's a mess. So during my spare time, I came up with a, you've seen this, everybody's seen this before. Your wire comes on one of these usually. Just look how nice and straight this is.
Is that long enough for 40 meters?
Now it is.
So anyway, I needed to come up with a way to keep my cords straight. I'll demonstrate it and then I'll show you how I made it. Everybody has one of these.
Cheating.
Power
Everybody has
tools.
one
I
of
like
these.
it. I like it.
Here, put your tongue on this.
When the HOA made me bring down all my wires, I had a lot of wire lying around. So I had to find a place to keep it.
HOA, is that a new word for while?
Whoops.
Oh, you went over the edge.
Fail.
Hi.
Fail, fail, fail.
That's my fault.
How did you satisfy
And you should wear gloves.
It stacked up his cords in a pile.
You can quickly and easily take care of all your cords. And you saw how easily it came off when I took it off. Oh, and you can ring in a big fish too. That's how it works.
Good job.
And this is how you make it. PVC, a coupling, the guides. These are plentiful. They pop up all over the place.
Oh.
Hey, Noel used to send them to you for free.
You can find these on most street corners.
What's your speech corner sign?
Vote for Johnny.
Yeah, during the voting season, they're really plentiful.
You're keeping America
And-
beautiful.
Well, and they're illegally placed, so you can pull them up anytime you want.
Technically,
Drill a little
no.
hole in there. Put them on. Get an end cap. Drill a hole in it. If you have a drill press, you got to have that straight out of there or it'll wobble, and that's not good. So if you don't have a drill press and your neighbor does, take a couple of homebrews down, have him drill them.
I had a drill press.
Is this the voice?
And,
Aubrey has a drill press, he'd like to make
and
that
you can
known.
do this in the garage while your wife is cutting quilts or whatever she's doing out there.
Awesome.
And that's it.
Thank you.
Anything you want for the deploy stick. This is just fiberglass rod, a screwdriver, any pipe, welding rods, whatever you have.
Cool.
16 cents and get you one of these.
Thank you, sir.
Plus the cost of the drill.
Yeah, plus the cost of the drill. Yeah. Mike said he'd let you have his.
$9.95 at Harbor Freight.
That's the right answer. What this ties into is that we've been talking about some build projects, and the build committee found a project that we'd like to try, and I just want to show a hands of interest. We've got a project on the left is the completed device. Peter, do you have one today? Nope, don't have one today. Peter has one of these and it works wonderful. It puts out a half a watt at 7.030 megasquiggles. You plug in a power supply, can be either a 9-volt battery or a 12-volt system, and there's a key that you can plug in the side. You can put your own key in the thing. So for what you see here, plus a few other parts, like a BNC, we got a dummy load, so you can actually just use it and do a dummy load and then pick it up on your own scanner if you want to listen to yourself. It comes in a piece stacked like this. So it is a true kit, back in the old Heathkit days to build it back up. Half a watt out, you can hook it up to a real antenna and talk to the world on a half a watt. Anybody here done a half a watt contact?
Life's too short for QRP.
Yeah. I was hoping Harold wasn't gonna be here, for a couple reasons, that's one of them.
Many years ago.
You can get across the world on a half a watt. They advertise this as 200 kilometers. So it's 120 miles for us Oklahomans is what they say they will get. What we will do is provide the kits. They're looking to be $10 for the kit. If you need a soldering iron, we can get those for $2. And we will put together a build kind of project where we'll put everybody in the room and say go. And you can continue it at home if you wish. And if you have any issues that it doesn't work, we've got a number of people that have volunteered to come help put the resistor in the right way or whatever the problem may be. Somebody's listening. But it actually comes, these little pieces are the plastic kit for that thing. Can I just get a show of hands, who would be interested in a $10 little kit kind of thing, just for quantity? Oh crap, I didn't order enough. I'm at 20, so okay. Pardon?
What frequency was that on there again?
7.03. 7030. It comes with, the kit actually comes, this is why we had to add a few kit pieces. It comes with a 7.023, I'm sorry, 7.2.
7.023.
That's it. 7.023, which is extra only territory. I didn't see any problem with it because I'm not an extra. I don't care. Get up there and pollute the other part of the band. Denny and I will be down here in advanced territory. But, you know, for legal reasons, we spent the extra 10 cents, so we're going to get a
Technicians,
technicians.
7025
Right.
to 7100.
This will be anybody can operate. Anybody has a license, let me put it that way.
That's right.
And it can use a key and read Morse code and all that kind of stuff. It is a transceiver, so you plug in a headphone, you can actually hear a signal coming out. Okay, let's just kind of a intro to see how much we had intro. How many of you that were interested would need a soldering iron? Oh, not very many. Good, okay. We might just we'll grab enough to, I figured there'd be a lot more. Okay, thank you very much. With that said, our main production today is supposed to be grounding and bonding. I'm Mark Kleine, I'm N5HZR, I'm a Big C trained instructor. And with that, I teach wiring and fiber optics, which includes the good skill of grounding and bonding. This is about a 7.5 hour presentation, so I'll be done in about.
See you next week.
Okay. No.
See you next month.
In the class, this is a 7.5 hour piece. We're going to take a lot less time. We're going to do a two-part event. This is going to be grounding and bonding will be the actual part of grounding and bonding. A big part of what amateurs think is grounding is what we use as counterpoise, or the negative side. We're not going to talk anything about that this time. We'll do that in a future event. So if you're wanting to say, do I need to hang a little wire off my end-fed wire, that's not what we're here to do today. We're talking the safety ground, the electrical ground. We will take the rest counterpoise, or how many radials do I have to put in the backyard so that the dog chews them up and spits them back out. Lawnmower, yeah, that's okay. We're not going to talk about that. We're going to do two things today, and this is what you got to remember. So there's a test at the end. You're going to learn something about a grounded electrode and a bonding jumper. For those of you that use the words grounding and bonding interchangeably, stop that. The idea of grounding connects an object to the earth. The idea is you want to make a good electrical connection to the earth's mantle, soil, the entire thing we stand on. The bonding jumpers are the wires that take that connection and hook it to something else. So two very simple concepts that take 7.5 hours to explain. So you have something in the ground, that's called the grounding electrode. That is the little device that we connect to. I don't know if any of you tried to plug your, your AC power cord into the soil to get a ground. That doesn't work. You gotta make something. So that's what we're trying to come up with those two. Here's the, be very careful. Peter, the as seen on TV is for you.
Yep.
Mistakes in grounding and bonding can be life-threatening to you or anybody that's coming. I have never gone to look at a grounding system and found the grounding system to be 100% correct. It's amazing how bad people can do stuff. Information is provide you background information. There's a lot of places to see. We'll show you where to go later if you want more information. If you're unfamiliar with grounding systems, please contact a professional assistance. I was gonna have the word professional help, and I think that was wrong. That's Aubrey's help, not. The problem I see is that I don't know, you gotta find a really good electrician if you're interested in grounding and bonding, because those guys get paid to do two things. Black to black, white to white, charge the people and leave. That's all those guys do. When you get into grounding, it gets to be more art than science. And you gotta take care of both of them. Your mileage may vary, oops, I typed that wrong. Your mileage may vary, and please allow $6.95 for postage and handling. Big thing is, why are we concerned about grounding? The grounding, this is from the National Electric Code documents, their definitions. They limit the voltage coming through the circuit that otherwise may come through from lightning. So if our friend Thor, Gary's friend Thor, comes and hits your system, you could have problems. Grounding limits the maximum voltage to ground under normal operating conditions. The idea is if you have a ground cable on your radio and you do not have it hooked to anything, which probably is everybody here, I'm not going to ask, this isn't a 12-step program, I won't ask if yours is all hooked up. That will limit that ground so nobody gets hurt, safety reasons. And then the bottom one is for the electricians more than for us, but that's what keeps their voltage regulation stable, so you get a good supply of voltage. Think of that as SWR for the power guys. They use that for that piece. This is really why we do it, V equals IR. Anybody remember this from your class? Yeah. If you lower the resistance, you find a good low path of resistance for electrical current, it will take that path. So we're there to make sure we get a good path to ground so it doesn't hit us. That's really the reason. Thor here. Denny got a lightning strike at his place that you think, I still think this, it came in through the phone line, is that what you're still thinking?
Well, I think so.
That the idea was a phone line was hit by lightning somewhere near him, mile, half mile, doesn't matter which, came in the phone line, and back in the old days when we had our 2500 sets, nobody here knows what they are, the little things that go dial-y, they weren't connected to anything. So if the phone lines got zapped, it would hook the phone, zap the phone out and take it away. Now, I have no idea what Denny had hooked up at home, but if you have a phone line, you're gonna have it hooked to a computer, an internet, a wireless system, all kind of wired stuff, your microwaves, your TVs, all of that's interconnected. And that's where we gotta work to get these things so that they don't take the current. This is the real, Gordon's asleep, I guess. I was looking for Denny's picture, and Gordon had two really good shots on his Facebook page that were awesome. Oh, there's Gordon, he's awake.
Yeah, I am.
Diggity, I stole this, thank you very much, Gordon.
Welcome up.
This one, do you know the details on this one?
On what one?
This picture?
I don't know anything about that.
You posted it a long time ago.
No, I didn't.
Yeah,
I
yeah.
That tree's now in my fire.
must have been asleep.
Asleep or drunk, yeah, that's it. The idea is a lightning strike comes down and you can kind of see here that it has hit this house and somehow it's snuck out, don't know how from this picture, but it snuck back out through the tree and picked up another path down to ground. I'd be interested to see what was down here. Is there a metal pole, is there a good low path to ground at that spot? I'm gonna make up a story and say, yeah, that's where the kids' play set was that had metal pipes on it, and that's where it was attracted to. I have no idea. But that's the kind of thing that you're looking at. This is another shot that you posted. Do you remember this one?
Wow, I must have been on the scotch.
Oh, my goodness. It was, this one was supposed to be Oklahoma City, and Gordon's comment was, boy, I hope they have a good grounding system. And that's kind of true. If the room lights are out, you can see this is the main strike. I'm sure this is a long exposure. This was the main strike that hit this antenna tower. Here's another one off of this one. This one has a faint strike out here, and this one has a faint strike out here. So it's not a matter of when you're going to get hit if you present stuff in the air like we do. It's a matter of when you're going to get hit. Typically, these take the best path to ground. I'm going to guess that this one is brightest, the center one is brightest, because that is the tallest piece and it took more strikes. It took more of the path on that main strike. I know nothing about any of these towers. I do know that, in answer to Gordon's question, they had to have pretty good ground to take that load. Now what happened to it when it hit the ground, that's the question. It's not that you're going to get hit, it's how that voltage hits the ground and does or does not do damage. Either come up with Denny's situation or they stay up and running. We had grounding conductors and electrodes. The grounding conductors, once we connect to something in the ground, we want to make sure, these are grounding. Once we connect into the ground, we can connect in this manner. We, if you want to jump to the bottom, that's what we typically know about, the very bottom one. Rods and pipe electrodes. Big 8-foot rod that goes in the ground. There are other ways to get ground. And in the good old days, we used to have metal underground water pipes. That would be a good way to pick up some ground. The metal frame of a steel building, anybody have a steel building at their house they live in? No, I don't think so. You do? All right. You can, concrete encased electrodes, they have special electrodes called UFers that go into the concrete, and you can connect to those grounds. So if they connect all of the rebar that's in the bottom of the concrete. Great technical piece of stuff to make that happen. One of the better ways, if you're looking to do it correctly, is a ground ring, where you bury a great big wire, say a 2-aught wire, in a big ring around your property, and drop in a number of ground rods as it goes around the house, or the building. Plate electrodes is just it looks like a big cookie sheet that has a wire coming off of it, and you can bury that in the ground. Other local metal stuff, piping systems, underground tanks, can all be used to hook grounds together. This is where it turns into science. You know, if you get a big project or really bad soil, you can use some of these other things. However, I'm going to say anybody that's doing any grounding in this room is using one of these, a ground rod. Yeah. This is a 1/2 or 5/8 inch, and just to make it clear, see the very bottom is steel covered. This is a steel rod that is coated in copper. It is not a copper rod. If it was, that would be a lot of money. It would bend a lot. So that's a copper coated rod. They make aluminum rods, but this one's a steel coated copper rod. Probably what you'll see anywhere you go to Home Depot, Lowe's, or Lock Supply.
Sorry to interrupt, but should lightning traverse that? Is it like RF in that it stays towards the skin?
Yes,
So it doesn't matter really that it's steel and
that is correct.
Can't hear the question.
The question was, is it like RF, as an arc, or, the question is is lightning like RF where it will scan a skin effect and it doesn't matter that the center core is steel, and the answer is yes. What we're looking for is that rod to make contact with the outside grounding, to take that charge and dissipate it into the soil. Installation methods, I've listed 4, there's a million of them. Sledgehammer, everybody know how to do the sledgehammer correctly?
No.
Have somebody else do it.
Yes, somebody else.
Have somebody else. The right answer is you take the rod, you beat it with the sledgehammer until it stops. Then you cut it off 6 inches from the ground. You beat it some more to make it look like you beat it all the way down to the ground. And then you connect them. Yeah, then you have another rod. You could go to somebody else's house and do the same thing. that's not the, I told the building inspector one time, and he just went pale. And he said, I've never thought about somebody doing that.
You're probably one of those guys that stubs the grounds.
Stubs the ground on a house?
Yeah.
Oh, that, when we, yeah, we can talk about that here at the end. I've seen those. We'll finish that up later. The easy way, electric hammer drill is kind of the same way. It's like the Mike method. You get the little electric hammer drill and you put a little cup on the end of it and it just drives it into the ground. That works out really well. The easy way is Gary's, which he brought so graciously. This is the water drill. He's shortened this one to 7 foot. We had one here before, but he's swedged the end, and I'll pass it out. I'll pass it around. And the idea is you put a hose on the end, you stand it straight up. I wish Wayne was here. We put Wayne on the top of the ladder because Wayne says that won't work. And was it 16 minutes? 16 minutes. We took a 10-foot pipe and had the thing in the ground, and we were gone in 16 minutes. You can either do what Gary's got and put the little connector on the end, or take a garden hose and just put some connectors on the side, squeeze them on there, and it works great. It will drive a hole straight down. Make sure you're level as you start, because was it you that found out, Ed, that when you turn it on, the water goes everywhere?
That was me.
That was Gary.
Oh, yeah. No, no. I stuck mine in the ground the first time. Stuck it in the ground, went and turned the water on, and it kinked over, right? The hose kinked over. So I go up the ladder, and when I straighten the hose out, all the red mud on the planet comes up in my face and under the soffit of the house. I'm laughing maniacally. My next door neighbor Tom is going, Gary, are you okay?
The first sign of a stroke is, okay, that's not a stroke.
Okay, I see how
Made
to
one
do
of
it.
these.
Yeah,
One of the things
yeah, I've seen how to do
here,
it.
Thank you.
one of the things I like
Take
about
one.
these
Oh,
is
okay,
that
yeah.
as you're going down,
That's an interesting.
you're also making sure that you're not hitting anything else important down there under the ground.
That's a very good point.
Yeah.
That you hit a fiber optic cable, you're more likely to glance off to the side. I've seen a 45-degree angle put on those, where you put a 45 on the bottom and you can kind of rotate it. Our soil here doesn't need that. Elmer?
I've got bedrock, it's about
Yep.
3 feet below my foundation.
Move.
Yeah.
Just pack it up and move. That's where we come into the electric hammer drill, and you're a good case for one of these other methods where you go get a grounding plate, where instead of drilling something 8 foot down, you go down to the bedrock and you put in a plate or a manufactured ground system. And there are all kinds. At the very end, I'll have a link to a company called Harger, Harger, and they have all kinds of that stuff. That's the science I was talking about. Is it
How
when
big
you?
a plate?
I'm sorry.
How big a plate are you talking about?
Well, the right answer is it depends. It depends on the surface area. They've got calculations that you can say, this is the ground rod, I'm gonna feed it with this size of cable. But you're talking this, you know, that kind of thing.
Question is, how much digging do you want to do?
Right, how much digging do you wanna do that's the big question,
I've got
yes?
the same problem he's got.
But-
I can get about 5 foot of ground rod in the ground,
Then you cut it off.
and then I hit bedrock. And at the house, my wife ran me out of the house and made me go to the shop. So the house is higher, I can get an 8-foot rod in at the house, but I can't get one down there, so
Yeah.
would I just maybe put a series of 3 or 4 rods in?
We're gonna talk about that as well, so that's yes is the answer. We'll talk about that in more detail, but that's a very good, that's the manufacturer, that's where we run into a problem. I'm glad we have a problem, yes, sir.
This plate you were talking about, do you put it in flat or can you put it in edgewise?
You gotta check the manufacturers on that. They have all kinds of different things. They actually have little L pieces that are chemical grounds that you put in like a 4-inch pipe that has copper on the inside, and there's a chemical inside that leaches out on a given rate, and you fill it up with more of their little proprietary stuff, and it goes down 2 or 3 feet, and you can put them with a trencher, I mean, that kind of level. So it depends on which ones you get. Whether you go vertical or horizontal or all kinds of stuff. I mean, there's tons. every problem that's ever been had has had a solution. I know of one that out on the west coast, it was bed of granite, and they couldn't get enough connection. So they drilled a 180-foot deep hole in the granite, put 180 foot of rod, they have threaded rods where you can just keep putting on them until they quit, and put 180 foot down and then poured in some kind of conductive grout. That conductive grout went in and put it down. That was to save a town. There's a Coast Guard ship in that town, and they have, there's Herald anode plates, sacrificial plates. They have plates on the side of the boat that will actually flake off the material if there's electrolysis happening. And yeah, those zinc plates would last, they're supposed to last a long time. These weren't lasting a month. And what they found out was that, a friend of mine went out there, what they found out was that when the ship was hooked up, it was hooked to the ground system for the electrical company for the town, and the ship was the ground for the entire town. A friend of mine went out there to do some training, and they had a ship that went out and dispatched, and as soon as he got there, well, they're all doing stuff, I'll just make myself comfortable. He grabbed a deal of popcorn out of the microwave, put it in the microwave, hit the button, and the whole place came unglued. Don't do that! Why? When the ship's gone, we can't do anything with microwaves, because the whole town has a problem, and we can't communicate with the ship. The guy went, no, we'll fix this. We'll fix it. That's what 180 foot ground. The town had to do a 220 foot in their granite. So there's answers. If you have these questions, I'll happy to hit you later on in the details. Harder or DX will be the ones to chase them down, and I've got those links later. But great questions. I'm glad you're at least concerned about it. That's awesome. Last method of installation is water cup and wiggle. Ed, have you done this? Report water cup down it?
And you said it bounce it? Yes.
Yes.
And it says 16 minutes here in Norman. It took me 32 minutes. That's double time.
So you take that same rod, you have a little water cup, and you just kind of pour the water down the rod, and you just bounce it up and down. And put it down, put it back up. And if you're patient, his story was 32 minutes, he put in an 8-foot ground rod with, I was going to say no skill, but that's kind of minimizing that great talent. Okay, no skill. And no material, no machinery. This is typically what you're looking at is a ground rod in place. My guess is this is the initial piece and goes into the house. My guess is this is a satellite TV that somebody added to the top of that. I would kind of like, this is a little grounding clamp that's hooked on there. That's okay. I would kind of like to see that with something called no-ox, and we'll talk about it here in a little bit, where it has a little corrosion kind of resistance. See, this guy did it correct. You beat the thing to the, you get it in the ground and then you cut it off. Yes, sir?
Yeah, Mark, they've changed the electrical code now. You can't use a clamp on electrical. You have to use a fuse.
Yes, you have to use, and we will talk about that.
Okay.
Very good. I'm glad you brought that up. I don't know where it's at. Coming up shortly. The idea is, if you pound that rod into the ground, these are what's called shells, and I got another better shot of it later. These are ground shells. The concentric rings that go around that rod is stepped potential voltage. When you stick a rod in the ground, you probably think, okay, it's 0 volts right next to the, it's immediately 0 volts. No, that's not true. Let's say you hit a lightning strike on this. This area out here is 0 volts. If there's 10,000 volt stroke here, that means the dirt halfway in the middle is going to be 5,000 volt dirt. So that's stepped potential. And that's where you've got to watch for the multiples, where we were with Dave, is that you've got to make sure you have a wide enough area to make that happen. We'll hit that in more details in a bit. This is a pit. This is one of those manufactured grounding pieces, and the same kind of thing. The grounding electrode goes in the middle of the pit, and it has some kind of magic inside, either chemicals or grounded or copper. Same kind of deal. Again, they're now saying you can't do this in an exterior location, and we'll show you what we do. Measuring ground resistance is that's another half a day task. The idea is you put this little megger on here. Phil's the only one I know that owns one. If he needs some help, he's got one. But the idea is you put one probe here, and the machine runs a current through that ground, through the soil. Don't touch those, they get really high voltage, not a good thing. Then you measure the voltage in, usually you use 10 different slots, so you do a tenth of the way across, you measure those, and you chart the resistance that you read. So here's pole number 1, here's pole number 2, and this is the resistance at this pole is 0 because you're touching the connector. At this pole, the far one, it's the highest because you're the farthest away from the meter. You can take 10 measurements in here, and that will generate this curve, this little natural S curve. To measure the ground resistance, you look at the 70, usually what they want is a 62%. So at the 6.5 foot mark, that's the one that you want to look at. That's the average connection that you're going to get with that wire. You just don't stick a meter in the ground and chase that. You've got to use the megger. Now, what you're looking for is this gorgeous little S curve. And if you get that, everything's good. If you get a straight line, or if you get a big box that goes in this direction or in this direction, that means there's something in the soil that's not working for you. One guy's, my question was, what do you mean? One guy said, I had it went 0 and then it went way up here and then went flat all the way across. And I said, what was that? He said, it was a 57 Chevy. They had dropped a ground rod in next to a 57 Chevy, and they were reading the soil right above that Chevy. So the ground was actually traversing through the car to get out. I said, what'd you do with the Chevy? Oh, we left it, it was all rusted. No. It was good for the ground plane. But that's the idea of reading that correctly. The fun part is, by the code, all ground connections must be measured at 25 ohms per or less. Anybody know any electricians?
Yeah.
They never measure the ground rods, ground connect. Do they? No. They don't have a megger. They don't know how. They don't have time. Neither does power company. Yeah, you're right. But the code says you got to put in 25. Now the crazy part of the code is, if it's less than 25 ohms, that's great. Well, for amateurs, that's not good. But for the code, that's what you have to do. Now the code says if it tests at 30, the code says, oh, just put a second one in, don't measure it, you're good. That's it. So, I'm not happy with that part of the code, but I think that's where we break into science versus art.
What about the sprinkler system?
Sprinkler system would be an awesome place. There was a guy, I saw a video preparing for this, that put a ground, he had this is what's called anal ham. He had a vertical antenna that he put in his backyard. He had a ground rod that he put right at the base of the antenna, and it was this far from the ground head, from the head of the sprinkler, so that the sprinkler would hit it, drop the water down there, and keep the ground watered. I thought, that guy's thinking. You could see sprinkler pipes again measuring stuff. You can see all kinds of crazy stuff. Typically, in the good old days, when we had $100,000 PBXs, we still do, but when they had $100,000 telephone PBXs, their contract said, when you install this, you must have a ground of less than 10 ohms. Well, nobody measured it, nobody cared, until the first lightning strike hit. And then the PBX manufacturer says, yeah, you know that $100,000 piece of stuff? Yeah, read this line in the contract. You didn't provide, we just measured your ground and it comes out at 12. And you're on your own. So there are references to stuff. Typically it's in court and in lawsuits. But that's never the fun part. Now, we talked about ground. We had our spheres, our little shells going around those rods. If you're looking down on one of those rods, the X and the Z, see how those shells create rings? The concept is you don't want those two rods next to each other because those rings will collide. And it's like Ghostbusters, you know, when the streams collide, that's bad.
Across the stream.
So the idea, it never crossed the streams. So the idea is you want to keep them apart, far enough apart. The rule of thumb is if you go 10 foot down with a rod, you want to allow 10 foot for the shell. So if these were 10-foot rods, you would place them at least 20 foot apart. There's our concentric shells again. Here's where we talk about size, location, and soil, temperature, and water content all matter. These are all charts that are in the references that we've got listed at the end. But for instance, if you see the different soil types, this is ashes, cinders versus sand. You can see the resistivity in ohms per centimeter that you see. So if you got a fireplace ash, that conducts 100 times better than the sand that we all have here in Oklahoma, or most of us have here in Oklahoma. Soil content, if you to go from 0 to 30% soil content, remember my story about the sprinkler? You can take your soil from darn near nothing and improve it significantly by keeping it wet. Yes, sir.
Yeah, I watered my ground the last couple of days.
You are awesome.
Yeah. Of course, my normal
Do you walk it as
water
well?
bill has gone up $10, but,
Yeah, that's because you didn't use anything. That's
Sir,
yes, sir.
you're, up there, it doesn't say ohms per foot centimeter, it says ohms centimeters.
Ohm centimeters. Thank you.
plenty of coffee.
It's
That's right.
do what?
That's correct.
Yes, that's the way it's listed as ohm centimeters.
I know, but what's the equation you plug that into?
For what? What are you trying to get?
I times R.
You're saying
What?
the value is ohms centimeters, so if you need dimensional analysis to get ohms, you gotta plug it into some kind of equation
Yes.
and divide by centimeters, right?
Yes. Yes. And it will depend on your centimeter. That's just a rating of.
What's the formula they plug it into?
Oh, I don't know. It depends what you're going to pull out of it, but it's a factor of resistance for a given distance. So soil moisture goes from 0 to 30, gets you a whole lot of stuff. Time of year kind of shows a deal of all of that, water and type of soil types. These are just two different curves that are listed. January through, it's 2 years, January through, or a year and a half, January through July, just two measured curves. 3/4 inch pipe, stony clay soil, the other one's in good soil. You can just see how it varies throughout the year. So if you get some, my antenna works better in a certain time of year, it may be true, it may be part of your ground story. The effect of salt, somebody here was talking about a salt water, dropping something in the salt water last meeting. I don't remember who it was. Can't recall. Is that you? Oh. The salt water, it adds a whole bunch. The salt. Here's one that's just my favorite. Good to hear this one resolution. 1/2 inch ground rod is 100% resistance. 5/8 gets you barely a little bit. 3/4 gets you a little bit more. 1 3/4 barely gets you something. You're talking about a big problem if you're using a non-1/2 inch or 5/8 inch rod. Bonding conductors. Code's a little weird on this one as well. By code, for a house or a business, small business, grounds are based on the number of phone lines coming in. The codes were developed because that's where the target was coming from. They say that if you have 1 to 2 phone lines, you could go with 12 gauge wire, 10 gauge wire for up to 6 phone lines, and then 6 minimum above that. Now the code also says you got to make sure it is significant. Everybody reads minimum 6 and they stop with 6. Have you done any more than bigger than 6 grounds? Fred, no. You just stick 6s.
Just 12.
12s and 10s.
Is the NEC still,
Oh, no,
Number of
no,
phone lines?
whatever, when we're wiring a building, we'll bring whatever power we bring in, whatever size, that's what we'll go ground with.
For the main line, and that's where they have to be sized to carry the maximum load. And that's where they get away with that by saying, okay, the minimum is 12 gauge, but if you have a double aught system, a big wire coming in.
Wire in, we go full out the ground.
Right. By code, they must be green insulation or marked as green. Green insulation, or marked as green means you take some green tape and you wrap it around the wire and that's it. Clean connections, we like that. Underground connections must be irreversible. Crimping or exothermic. Anybody know what exothermic means? Fire. Gary and I are gonna try some, is what he's saying.
Oh, yeah.
And we're gonna bring some videos. But the idea is you light off some metal and it will actually weld in place.
Yeah, thermite, right.
Yeah, it's like railroad ties.
Yeah, Mark, actually, the code now requires this even above ground, the exothermic.
Exothermic, but only to what point?
That you have to, any ground from your house has to be permanently fused to your ground rod. You can't use clamp anymore.
But to get it to the house, but up to the main grounding block.
Oh.
You don't have to do it in the house.
No, not
Just
the main
the
grounding block, you're using
just the main line that goes into the house.
Yeah, you're not worried about corrosion in your main box, but you're worried about corrosion. That's the issue on the grounding rod.
And the reason is, the code also said, annual inspection must happen to inspect and tighten the entire ground system.
That's funny.
Did you tighten your ground system before you watered it?
Yes, I did, I checked it.
That you got. I have done this at my office and solved a lot of problems where we just run through and tighten everything off, and you get a lot of computer-related issues that go away when you do get a better ground system. My electricians just think I'm an idiot. Of course, they're the ones that take the brown gardening gloves, and they take a socket, and that's how they tighten them all up. And I'm leaving. That's their insulation.
That's wrong?
No, it's perfectly okay.
I offer to water the grounds. What are the water the gloves? What Fred's talking about is the ground. Here's the electrode outside going into the building. Those main connections have to be irreversible. You cannot, you can't do a connection on those. This is the idea of tying everything together. So if you've got any pipes going anywhere, if you've got water, if you've got a metal stud or a metal framed building, if you've got all kinds of radio gear, you want them all connected to one spot. When you get that lightning blast that Gordon showed us a picture of, you want the entire ground system to go up and then come down at the same time. You don't want any differences or potential between the entire system. This is what it looks like inside your box. Hopefully a little neater than that, but that's inside your box. The ground system's coming in. This is not a ground.
It's okay, you can try the exothermic.
I think that was a cigarette butt.
That has potential.
I don't know.
Now, that was a gas line, I believe you hooked up.
Well, I thought that, but it's got a copper coming out the top. I don't.
But it has potential.
It has potential. Huh? Grounding bus bars for telecommunications. This is what we should be using in our stuff. This is a shot from my office.
90 bucks a pop.
Is 90. This is a shot from my office. What we do. By code, this is the one that goes back down to the ground rod, and you can tell that because it has 2 bolt holes. And you can tell that because this connector costs $2.70 and this connector costs 70 cents. Yes, sir.
These can be sourced locally at Synergy Data Home in downtown Oklahoma City.
Synergy has them. Granger has them. Harder has them. DX Engineer. But the right answer is, this is for my office, and these go off to different rack devices. But this would be the connection that goes out to your outside piece. This is the piece that goes to the water pipes. We've got copper water pipes, so that one actually is the water. This one's the phone ground, goes to the phone system. And then each one of these would go off to your different radios. So if you've got a way to do this behind your radios, you're in great shape. Yes, sir.
So would you, like, I've got the Kenwood system that's got, you know, the power supply, the radio, the tuner, and every one of them's got a ground, so should I do that? I mean, I've got one of those ground blocks.
Yep.
So you would ground each one individually like that
Correct.
to the,
And the reason why, well, we'll talk about here in just a second, but yes, you want to run a separate line for each one of those devices. You don't have to do it for your walkie-talkie. They ain't no place stuck it.
put a screw in the bottom of it, right there by that brass, you know, that copper thing.
If it's not there by the manufacturer, you don't have to do it. You can, if you got a screw loose, you can do whatever you wish.
If you're gonna do equipment, it also helps if you run all the ground lines the same length.
For amateur radio equipment, yes. Same length. You also want to make sure you don't do sharp corners. You can see they're kind of nice, lazy corners. For us ham folks, one other thing that you might wish to look at, I'll pass these two around. These are lightning protection devices. These inside these blocks have a little gas cartridge. And when these go, when the voltage between the center pin and the outer conductor go greater than 90 volts, it starts to short out that center pin to ground. So if you get a close hit on an antenna, you have one of those tabs that's on the device that's going around, and one of those tabs would go to this block. It would go straight to that block. Michelle's got a good one where she has all of her connections outside, and she pulls them. And that's fine, but remember, you still, if you get an antenna up there, you still, if you're not connecting those two together, you still got to wait for that electricity to be a potential. And John or Rick Graham, one of our local hams, works for the county, had pulled his on the inside, and he literally was sitting there when he had it laying on his wooden bench, and he saw lightning hit, and it spark gapped that PL259. It spark gapped it and jumped and heated up the entire bench and blew out not only his radio gear, but literally took the switches out the wall and blew them out of the wall physically. I've seen that happen on a half million volt power line happen, same thing. But it will pull it out of the wall, and he blew up every ceiling fan in his house. He thought he was doing good by unhooking it, but there was nothing for it to go. It was grounded, but yes, sir.
You don't have to have a lightning strike to ruin your radio.
Oh boy.
If you have a dipole and there is intercloud lightning above your house and it's strong enough or close enough, it will generate enough potential on either leg of the dipole to short through your radio. And that'll make your day.
That's where these devices going across are wonderful, because they will jump in when it goes over 90 volts and short it out and take care of that situation. But you're exactly right. That's typically to spark gap something, you typically need at least 5,000 volts per centimeter. So if it's 2 centimeters, it's 10,000 volts.
On your bus bar, how long is that to ground, that top one, the double,
This one?
Yes. Everything you read says, keep it as short as possible, keep it as short as possible.
Keep it as short as possible is the right answer. It depends on the situation. This room goes up and 8 foot over and 8 foot down, so it's probably 18 foot long. That affects how big a conductor you need. So if you go longer than that, you just have to size it up to a bigger conductor. So the shorter you are, the better you are for load. Longer requires a bigger. I've seen stuff where we've had to pull in 1/0 ground wire to do something like this. A building on campus, to be not named later, physical sciences, has one of these up in their upstairs room. Has all kinds of stuff hooked to it. Everybody thinks they're grounded.
Yeah.
This wire is not connected to anything. So they're all connected to each other, but that's it.
That loose coil of wire is properly secured.
Loose coil wire is properly secured, you're right.
Where it's
We
supposed
verified
to,
that.
yeah.
Should you use solid wire as opposed to braided?
Doesn't really matter, that's just, whatever you got.
I got a bunch of braided.
Yeah, just as long as the current carrying capability is there. Copper water pipe connection. That's where they clipped on the water pipe. Testing a ground, this is probably what we're all used to. If you got a ground cable, you want to check the ohm meter, you check the thing. That's the same thing you do in a big ground system. Usually you have larger leads where you're going 100 foot or so running across the building to check that.
It's not a good idea to tie it to a water pipe. Electrolysis will flow through that water pipe and eventually it will pop out and it'll cause a leak in your water line.
Yes.
Seen it many,
It is code, though.
many times.
Lightning arresters is the one, oh, there it is. This is what I just showed you passing around, polyphasers version. They're typically in a rack mount situation, look like this, where they have I can't see it, it's a green line going off here to the ground. There's another line that goes off to the ground. And those are a bunch of different polyphasers. That's what typically looks like. It's what our repeaters got, 3 or 4 of those in there that make those connections. Conductor sizing, we talked about kind of. Back up, okay.
Is that a copper plate behind it, or?
Yeah, that's a copper bar. That's an L-shaped copper bar.
Okay.
All of those are just bolted in through the face. They're just a longer protrusion. It just bolts into that rod. Yes. Sizing, there's a chart, electrical, NEC, the National Electrical Code has a chart for sizing. They typically say, depending on what wires come into the building, what your minimum grounding should be. Our good friends at Motorola specifies 2 wire gauge in all of their stuff for document installs. They typically say 2-0 or 2-0 for all of their tower work is what they usually run. The big thing here is that's all the backbone wires. Obviously, if your radio doesn't have anything bigger than a 6-gauge connector coming off the back of it, all you have to do is run 6-gauge back, unless it's a longer distance. Bill, here's your answer. It should show distance here. No, it doesn't. Yeah, this is distance. So figure that out, do your math. That's where the science comes in with the electricians. Watch on the copper to aluminum connections. You want to use a product like Noox. This is a Noox, or a Deoxit is another one that you goop on those devices when you put copper to aluminum. That chemically fixes it. That's Ed. If you got to ask Ed, or if you got a question, ask Ed. He's the chemist.
Electrolysis tears them up.
But this stuff is supposed to take care of the electrolysis problem. I talked about earlier why you don't want more. Why you want to make sure that you have, if you have multiple radios in Dave's situation, you want to run. Here's your grounding protection. You want to run a radio ground and a radio ground to the second radio. If you do that, and then you connect them with a little piece of audio wire, say you have 2 radios and you're hooking the audio of the output of this one into the input of the other one, that gives you a chance for a grounding loop. And that's, we've talked about it, somebody said earlier, grounding loop situation. And the idea is that it may be a little less resistance this way than this way. Let's say the lengths are different. Back to the earlier stuff on Lee's portion. If this was a 200-foot run and this was a 10-foot run, there's less resistance here. This little audio line may pass ground current on that ground line. And you will get little ground ripples and you'll get ground hum. Anybody heard ground hum or ground loop? Yeah.
Yep, it's right in that video.
Right. Right, what? Oh, in your video?
No, in this one.
Oh,
That you're
yeah, what
making
you're seeing
now?
here?
Oh.
Yeah.
Yes.
Exactly right. The image bars is what Michelle said here.
Oh.
But this is ground hum. Typically what you do to fix that is you will cut either end. Bob Heil says this, and he says it many times if you listen to his podcast. You cut either end. The line is still shielded because the ground potential is the other side. You just stop that secondary path between those two.
Pin 1 issue.
So it's not a problem with the system. It's a problem that this one has a little higher resistance than this one does. Ground fault interrupters. Everybody got these at home? I've got one that when you hit the, yeah, you better, if you walk by with my DMR talkie, it will blow it off. You got one of those? Scares the dickens out of me every time I walk by into that hallway. Oh yeah, when she's blowing her hair, right, yeah, that's. The idea is this device will trip if there's a current on the ground line. And that current, the current, 6 milliamps worth of current or above is enough to stop a heart. These are triggered to stop at 5 milliamps of current. So if it gets 5 milliamps of current, it blows. So that's what happens when you blow it. When Mark walks by with his talkie, and Chris walks by with his talkie, there's at least 5 milliamps worth of current on that ground line, and it shuts it off immediately. I've tried this with a set of resistors, and it's 5 milliamp. It drops right when it's supposed to. You just put a couple bleed resistors in there, and it'll make it happen.
Need a lower power.
Lower power.
Handy talkie.
Oh, handy talkie? Yeah, yeah. Or just stay out of that part of the house. Anybody know these?
Equal.
Anybody happy with these?
No.
These are what's called arc fault interrupters. These are the new version of the ground fault stuff. The idea is this breaker goes in your breaker box and it will trip when it senses an arc on the load.
Or a vacuum cleaner.
Or a vacuum cleaner. Now, all you with these stories are talking about the earlier versions of these. The earlier versions of these falsed horribly, horribly. The method has changed. They are required in the living areas of your house. I'm not going to say who said this, but I know people that put them in for code inspections, and the electricians come back and find that those breakers need to. Oh, Chris, you did that too, huh? They pull those arc fault breakers out. That happened in the olden days, early stuff. The new ones are better. We put one in a new house construction. They used to trip on 30 milliamps of current, like my other one did, and you can get that from a vacuum cleaner. Not a good way to do that. The brushes put out enough stuff to give a problem. These, we hooked one up on a circuit and it kept tripping. Finally found, had to go through the whole circuit and figure it out. The electrician had installed put a loop, just a hook on the wire, and put it underneath a screw connector, but put an extra loop on it, and it was very close to the case on a metal device. That was enough to draw an arc that would trip it reliably. And, in my mind, that was a good thing, because that means, hey, you're going to find the problem. What they used to do, if you look at this nice pretty sine wave, is they used to look at these peaks where the current and voltage were going nuts, and they used to say, oh, there's a problem, and they would shut it down. And that was easy to misread as a vacuum cleaner. The current way they do it is they look at the sine wave, and they say, oh, I lost my mag. They look at the sine wave, and if the sine
There's
wave...
an arc fault interrupter on
It did. One of the ends is probably out of a battery. If they look at the sine wave and it's distorted at the back end of the sine curve, it knows that's an arc problem, because any of these little issues that happen, a transistor or a triac will come in and switch, and it'll delay the on time. So the front side of that curve, this kind of curve, it will ignore. So a whole lot better. Good timing. What'd you learn? You had two things. What were they?
Let Mark do it.
Grounding and bonding.
Good. Hopefully you got all
Call
that.
Mark, he'll fix it.
That's right. Call Mark, he'll fix it. This is more information. What you really need to know is that on the w5nor.org, either /events, I've got it there, and I just built a grounding page this morning. All these links are here. Harger and DX Engineering are good suppliers to get. Synergy, I guess, has got a bunch in Oklahoma City.
Yeah.
These documents are going to be great for helping your guidance on that. There you go. There we are.
MTV.
MTV, gosh. That right there. Good. Thank you for your attention. Any questions?